Okay, this is lesson 7.1b. We're going to talk about squares and more squares. Um, the first thing we're going to do is we're going to use the grid paper that's in your notes, and I'm going to have you create as many different squares from areas from 1 to 100 as possible on the grid. So a horizontal or a vertical segment joining two dots has a length of 1. So one block is 1. Each of the vertices of the square must be on a dot. You can't draw diagonal. Find the area of each of the squares you made and label each square with the area. Complete the table at the right using the squares you created. So here I want you to stop for a minute and I want you to draw squares. So here is an example. That square has a side of 1 and a side of 1, so the area is 1. So here's one, a square that's each side is 2. 2, 2 with an area of 4. So draw as many of those as you can, and you can stop the video, and then we will go over those together. So these are just a few of the examples. My space is a little smaller than yours. You should be able to come up with a few more. So let's go over these. So if you have a side length of 1, the area is 1 times 1, 1 squared, or 1. If you have a side length of 2, which is this one right here, 2 times 2 is 4, so you have an area of 4. If you have a side length of 3 units, your area is 9. If you have a side length of 4, your area is 16, like this one right here. You have a side length of 5, your area is 25, and I know that you don't have all these spaces, but you could just keep going. If you have an area of 6, you're at 36, 7, 49, 8, 64, 9, 81, 10, let's go to 100. Okay, so the relationship between the side length and the area of a square is you take the side and you multiply it by itself, which is squaring it. So now let's look at another table. Now we know how that works, right? To get from the side length to area, you square it or take it times itself twice. So if the area is 1, you're going to go the opposite direction. If the area is 1, to unsquare something, you take the square root. A square root is asking you ask yourself, how many times itself does it take to get to what's under the square root symbol or the radical sign? So that's 1. So if you have an area of 9, if you look back here, an area of 9, you had a side length of 3, or the square root of 9 is 3. The side length is 3. If you have a side length of 5, we want the area, so you're going to square it, or take 5 times itself twice, so that's 25. If you have an area of 2 square units, you're going to take the square root of 2. Well, right now, there is no whole number. There's no number that you can multiply by itself to get to 2, so that's a decimal. So we're just going to leave the side length as the square root of 2. If the area is 5 square units, there again is no number that you can multiply it by itself. That's a whole number to get to 5, so we're going to leave this side length the square root of 5. If you have a side length of the square root of 13 and you square it like that, if you square a square root, then you just get rid of the square root symbol. So the area is 13. Same here, the square root of 5, the area is 5. If you have an area of 100, the square root of 100, or what times itself equals 100, 10 times 10, so that's 10. Side length If you square 20, a side length of 20, 20 times 20 is an area of 400 square units. It's a lot of going back and forth there. All right, 2A. If you have a side length of 11 centimeters, to get to the area, you're going to multiply 11 times 11, or 11 squared, which is 121. When you're talking about area here, your units are always square units, so it's square centimeters. This time, we have the area of 16 meters squared. We need to take the square root of 16, or ask ourselves, what number times itself will get you to 16? That's 4, and the units is just meters for that side length. All right, number 3. Let's, it says, complete the following sentences and provide examples to support your statements. A perfect square is created when a whole number is raised to the second power. Here's an example. 3 squared equals 9, or 4 squared, which is 4 times 4, equals 16. To find the area of a square given the side length of the square, you square the side length. These 3 statements are really important. Square the side length. So to find the area, you square the side. Number 5, to find the side length of a square given the area of the square, you take the square root of the area. So the side length is equal to the square root of the area. All right. Now, these all are perfect square roots, are perfect squares, which means they will have a whole number square root. These are things that you're going to have to memorize, and we'll work on that in the upcoming days. So the square root of 36, or what number times itself is 36, is 6. That means 6 times 6 is 36. The square root of 1, or what number times itself equals 1, would be 1. 1 times 1 is 1. The square root of 65 is 25. That means 25 times 25 is 625. The square root of 121 is 11. 11 times 11 is 121. The square root of 100 we already talked about. 10 squared is 100. 10 times 10. The square root of 2,500 is 50. 50 times 50 is 2,500. That's 50 squared. The square root of 16. 4 times 4, or 4 squared, is 16. The square root of 49. 7 times 7, or 7 squared, is 49. And the square root of 225 is 15. All right, that's it for this one.